Hey everybody, in this video we're going to practice graphing at the function graph given the derivative graph. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now here we're given graphs that are the f prime graph, and what we want is based on that to graph the original function graph. So as in the other video where I said the first thing I look for is when the slope is going to be 0, I look for the same thing here. That is, when does f prime touch the x-axis? Anytime f prime touches the x-axis, we have a slope of 0. And we do, right here. At this point, f prime is 0. So that means on our graph, our function is going to have a slope of 0. Now on this video, unlike the other one, I'm not going to be labeling the x and y axes, because going from f prime to f, the y values don't matter very much. What matters is the shape. And so I'll start at the origin, but I don't have to. And that has a slope of 0. And then from there, what happens is the slope starts to increase, starts to go up. And as you go further up, and you go further to the right, the more the slope goes up. Now from this point, as you go to the left, the slope becomes negative. Now be careful. Don't draw it downwards, because that would mean a positive slope. That would mean it would look like this. So this is the f prime graph, or f of x graph. And if you think about it, if f prime is linear, that means f of x should be quadratic. And that is the shape that we have. So looking at number 2 now, here we have a quadratic, and here we have a slope that is 0 at x equals 0. Now what I'm going to do here is I'm going to put my point at x equals 0 not on the origin. I'm going to put it up here. And that is because the y values tend not to matter, because I could add or subtract a constant from f of x and it won't show up for f prime, because the derivative of any constant is 0. So that means from here, from this spot where the slope is positive, or 0, it now becomes positive. And so I'm going to go up like this. Now as we go off to the left, the slope is also positive. But that doesn't mean it goes up. That means actually that it goes down. Why? Because think about the slope of the tangent line. We want the tangent lines to be going up. And so here, the tangent lines would be going up, whereas up here, the tangent lines would be going down. And so that's where we want to think about. Here we have negative slopes for our tangent line. Here we have positive slopes for our tangent line. Now looking at number 3, here we have a graph where it doesn't touch the x-axis, so there is no spot where the slope is 0. But we do have slopes that are always positive, and they're always growing. So because they're always growing, that means this is an exponential graph. And like exponential graphs, what they do is they will start horizontal on one side and then grow on the other side. And so that is going to be what our f of x graph could look like. Now, it could also be down here. And this is why I'm not drawing values on the x or the y axis very much, because you could shift this graph up and down and the f prime graph wouldn't notice the difference. All right, on to number 4. Here again, the graph doesn't touch the x-axis, so f prime is never negative. So here f prime is very, very positive, and then it's getting closer to 0. So here is where it's leveling out. Here, f prime is negative, slightly negative, and then coming down and becoming even more negative. So we want a negative slope when x is negative and a positive slope when x is positive. So what that will mean is we want a slightly negative slope, and then it goes down, down, down to an asymptote. And then we want a very positive, so that means an asymptote going up like this. And so here is what f of x looks like for number 4. Looking at number 5, there are 3 spots where f prime is 0. One here, and since this is a sinusoid, we know that there's going to be a spot here where f prime is 0. So we have 3 spots where we have a horizontal tangent. Now at 0, we start with a slope of 0. So we'll put that right here. And then what happens? It goes up and then reaches a maximum value. So that's where the slope is going to be steepest. So it goes up to about 1 to 2, and then it starts to pitch over. And so there's my second point right there. Here's the first point where the slope is 0. So working backwards now, from here to here, the slope is negative, negative until it becomes most negative. So it's going to curve upwards like that. And then after that, then it's going to start to level off again. So here's that third point right here. And as a reference, this spot right here and this spot right here, I'll label these in red, they happen right here. These are our points of inflection. Between here and here, the slope is negative and it's becoming more negative. Whereas here it's negative and becoming less negative. It's approaching 0. Between here and here, the slope is positive and getting more positive. It's curving upwards. Between here and here, the slope is still positive, but it's becoming less positive. It's flattening out to 0. For number 6, we do have one spot where the slope is 0, right here. That's where it touches on the x-axis. And then to the right of that, it starts to become positive, positive, and as it approaches 4, it becomes almost infinitely positive. So we have a slope of 0 right there, and then 1, 2, 3, 4. I'll mark that asymptote as a reminder. So up, 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 like that. Now off to the left, we have a negative slope until it becomes almost infinitely negative the other way. And so that is going to be 1, 2, 3, 4. So that's going to go up, 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 like that. So there is our f of x graph. All right, number 7. Now number 7 has 2 locations that touches the x-axis, here and here. And so those are 2 spots where the slope will be 0. Now since we have specific markers right there, I'm going to mark those spots on the x-axis. And so at this spot, at -3, we have a slope of 0. Before that, we have a slope that is positive and steadily becoming more positive as we move off to the left. So that means it's going to curve down like that. Between -3 and 0, it becomes more and more and more negative. So I have to keep curving it down until I reach 0. Only then can I stop curving it down. And then from 0 to 3, this is when I have to start bringing it back to a slope of 0. And then after that, now it becomes positive, and it's going to keep going up more positively forever. So this is what our f of x graph should look like. So on number 8, here, f of x is 0, if f prime is 0 all along here. So at all of those spots, it's going to be horizontal. So let's mark that. So for an entire stretch, it's going to not go up and not go down. So all along here, it's flat. Then what happens? Then it switches and has a slope of 1 between 0 and 1. So now it's linear, but has a slope of 1. And then from 1 to 2, it has a slope of +2. So now it switches. And so at each point here, it doesn't curve, it bends. And so it has a distinct bend to it. Between -2 and -1, it has a slope of -1. And then before that, it has a slope of -2. But each of these points are not differentiable. Each of these points has a distinct bend in them that isn't a smooth curve. And so this is reminiscent of the graph that you see in number 9, how that one works. Except for number 9, this one is the graph of f prime again, so now we have to draw the graph of f. Now, there is no value at which the slope is 0. So here we have to look at this and say, well, between -3 and -1, the slope is always 1. So I'm going to start down below because this is always increasing, so it gives me some room. So this has a slope of 1. And then from -1 to -2, it starts to grow. So that means it starts to curve upwards. And then it starts to curve upwards even more. So here is what our f of x graph will look like for number 9. So for number 10, here we have one spot right here where the slope will be 0. And then from here onward to the right, it's going to approach a level value of about 5. And then off to the left, it's going to approach a value of about -5. I'm going to draw this one down here. And so as we grow and as we approach a slope of 5, what happens is the graph starts to become more and more linear. Because anytime we see a horizontal f prime graph, that means that f of x is going to be linear in some fashion. And here we should have a slope of about 5. Backwards this way, we should have a slope of about -5. So it's not quite a parabola, because a parabola would keep curving upwards and inwards, whereas this one, the further out you go, the more and more linear it becomes. And parabolas don't do that. They curve forever. Now number 11, this one, we have a point at x equals 1 where the slope is 0. Between 0 and 1, we have slopes that are negative. As you get closer to 0, they are infinitely negative. And then as you go onwards from 1, they increase over time. So we have x and y, and we have our reference point at 1. So here, now before that, as we approach 1, that's infinite, so that's an asymptote behavior. And then as we move onwards, curves upwards like that. And so that is what our f of x graph. Between here and here, the slope is negative. You get closer to 0, becomes infinite. So that's an asymptote behavior. Off to the right, keeps gradually going up. It never flattens out like this one does. This one flattens out, but the logarithmic graph always grows, which means this graph always has some more curve on it. And then for the last one, we have a slope of 0 here at -5, and a slope of 0 at 5. And then from -5 all the way to 5, the slope is always positive. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we start with a slope of 0. We'll start this one down here, and we'll bring it up, and then it grows, grows, grows until it reaches 0. Becomes more and more positive. And then from 5, and then from 0 onward to 5, it's going to level out. And then the graph stops. Whoops, got to keep going to 5. Because the graph of f prime stops at 5, the graph of f of x also has to stop at 5. Their domains are the same. Thanks for watching. If you liked the video, please give a thumbs up. For more videos like this, click the subscribe button. If you're a teacher, please consider sharing this with your students. If you're a student and you like it, please share it with your classmates. If you have a suggestion or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the only way to understand something is to do it.